Yes. Hello, everyone. I'm Roman. I'm a researcher in Fireblocks, and today I will be talking about building a trustless light client assistant in your browser. I will share insights we've gained from working with light clients, from developing with them, and what you can actually use them for right now. So even if you know nothing about light clients, or you kind of know everything about light clients, I think you will learn something. So let's dig in. The agenda for this talk, I will talk about the problem and why we got into light clients. I will talk about the solution and what we actually built. Talk about developing the solution and the process and what tech is available. Light clients as trustless verifiers, the specific use case and what does it mean, and what we would like to see in the future, what we expect to see in the future, etc. Okay, so let's get right to it. Why we got into light clients? So for those of you who don't know, Fireblocks, the main kind of core business, is an institutional wallet provider. So let's talk about the wallet trust model. How does it look like? So we have blockchain data, right? It's the source of truth. It's what we all agree on. And we have the wallet providers, which run nodes and get information from the blockchain. The wallet providers have clients which get information from them, which is relevant to them, such as transactions, balances, NFTs, all kinds of blockchain information. And the clients can ask themselves, is the data I'm seeing is like true? Is it correct? Is it verified blockchain data? So it's a good question. And how can the client answer that? So one kind of naive solution, the client can run his own node and just compare the data he's getting from the wallet provider with the data he's seeing in his node. So okay, it works, but it's not a really good solution. There are many problems with that. But one of the main problems, it's not really easy to run a node. It requires lots of resources, storage, compute, network. It requires some setup and sync time, and you need to know what you're doing. So it's not straightforward. Also, if we're talking about more complicated scenarios where the client has its own clients, end clients, which also ask themselves, is the data I'm seeing is verified? And this end client, if we're talking about wide crypto adoption, it can be any kind of user, it can be your grandma day trading on your phone. So she isn't going to run a node to verify the data she's seeing. And also, we have more complicated scenarios, and we keep adding hops of trust, right? So we are more disconnected from the blockchain, so it becomes more complex. So we are saying trust but verify. It's a good slogan. We all like this statement. But how? How can we actually verify? What tools do we have to verify the information we are seeing? So we started the research there, and we found kind of a solution that looks promising, which is light clients. So very quickly, what are light clients? I won't dive into how do they work. You can look it up online, and I will focus on Ethereum light clients. So light clients kind of just enable us to track the beacon chain, the latest blocks, in a low resource environment. So if you want to run a regular node, the regular consensus, you need like hundreds of gigabytes of storage and all kinds of network operations. And light client allows you to do that in a much more lightweight way. And you can run it in a phone, in a browser, in a low resource environment. This is kind of all light clients provide you. We will talk later about how we can actually use it to verify blockchain data. Okay, so we understood the problem. We want end users to verify what they are getting from various sources. Let's see what we built. So we built an open source Chrome extension that allows you just that, to verify blockchain data from various websites. It is open source. You can check the repo. You can check the Chrome extension. It's in the Chrome Web Store. And currently it supports varied data sources, but it's pretty easy in the code to add more data sources. So we support a kind of wallet web interfaces, chain link data feeds, Etherscan balances. You see, it's pretty easy to add any kind of website that displays blockchain information. So the whole, what it adds to your page, it just verifies the information, a little checkbox, if it's verified and at what block was it verified. Or if it's not verified, you will see the message accordingly. So let's focus on Etherscan, for example. Probably you didn't know that, but Etherscan provides like an option to validate an account balances. There is like a hidden button there. And what it does is just queries multiple providers, what is the balance of this account. It supports just native balances and not token balances. And there are still problems with this approach, and the UX is kind of not there. So what we kind of transition into, you just open Etherscan and you see, is it verified? And you don't need to trust that Etherscan is doing something correctly. You just trust the light client. So kind of the high-level architecture of the extension. So we have the various web sources. We have content scripts injected into them. They extract the data which is relevant to be verified, such as the balances. It is sent as a request to the service worker, which is running light clients for each supported chain in the background, and they sync continuously, so you don't have to do nothing. You can just verify. Okay, so we saw the problem we had initially, right, to verify information we're getting. We see one possible solution, a Chrome extension which incorporates light clients. Let's talk about now the tech, how it works, what are we dependent on. So we didn't try to develop everything from scratch. We looked at what are the possible solutions. We didn't even know initially if there are possible implementations that are currently working. So if we kind of imagine a light client as a primitive that can verify information for us, how would we incorporate it in our code, right? So for those of you who are familiar with Web3 development, you know the concept of a Web3 provider, which is like a central point in the code, which is used to interact with the blockchain, get information, all the RPC requests pass through it. It's one central point. So if we have some primitive that allows us to verify information, it would be cool if it was just incorporated into the provider. We didn't have to change anything in our code, and everything will just be verified, kind of a utopia, right? So actually this utopia exists, and there are two current mature implementations that do just that. They implement both the light client and the verification part of it. So we have Lodestar and Helios, both great teams, which kind of provide a wrapper for the provider, which you pass a few parameters related to the light client, and then you have a Web3 provider which just verifies all the RPC requests you do through it. So pretty amazing. So we said all RPC requests, but it's not really correct. You need to, depending on your use case, to check if your RPC method is supported. For our use case, we just focus on if call. So it's supported in both implementations, but it's something to consider. The verification isn't generic. You need to implement per RPC method how you verify this information. As we said, the light client just provides you a way to track the beacon chain. So it doesn't provide the verification part. So integration and interaction. So Lodestar is written in TypeScript. So for a web application such as the extension, it's pretty straightforward. It's also written in TypeScript, so you can do cool things like hook on when you get a new block, you can re-verify the information on the page and update the block. It's pretty cool. Helios is written in Rust, but they did great steps to support web applications also. They support now WebAssembly and TypeScript bindings, so you can also use that. We plan to incorporate it in the extension as well. So we worked closely with the teams. Open source is great. We really support like the ecosystem, and everyone contributes. So we had both discussions about light client architecture. We submitted bug fixes. We talked about possible features, and we worked with them really closely to make the extension, like the vision we had, happen, but also to support future use cases. If any of you will have a use case, you can talk with the teams. They are super cooperative, super professional. So again, open source is great. You can check out the repo, submit your PR, submit issues. Okay, so we saw the initial problem. When you want to verify information we are getting, we saw the solution we did. We saw that there are available implementations you can build upon. You don't need to start from scratch and look at the light client protocol standard and start to develop it. So that's super great. Let's talk about the specific use case of the trustless verifier light client. So we said light clients just track the beacon chain, and the verification is something that was implemented by Lodestar and Helios. So we kind of skipped until now how the verification part works. So we'll go through it now. And we keep saying trustless, but as a few skeptics in the crowd probably will ask themselves, is it really trustless, and what do I mean by that? So the verification, we'll talk about verifying contract calls, which what we used it for, because the balances are just a contract call of balance off, etc. So, okay, the flow looks like we first build a local state we trust of the EVM parameters needed to execute the EVM call we want to run, and then we just simulate, kind of run the call locally on this trusted state. So how do we build this trusted state? We don't want all the EVM state. We care only about specific parameters that are related to what we are trying to get. So if we are talking about verifying ERC20 balances, we want the specific storage slot of this ERC token, etc., the contract code. So we get all this information to create the sub-state that we need to run this contract call. How do we know which sub-state we need? Luckily, there is a RPC method, create access list, which provides us all the parameters which will be touched by the transaction that we want to run. So we get all the relevant storage slots, accounts, contract codes, etc. So we get all this information, but now we need to verify it. So we get all the Merkle proofs necessary to verify this information. What do we verify the Merkle proofs against? So the Merkle root is in the beacon block, which we track with the light client. So the state root is in the beacon block. We verify the Merkle proofs against that. So we have a sub-state, which is verified, but we can run our contract call in. And then we have our own code, which we audited or something similar when we trust, and we just execute the call locally. So that's kind of how you verify a contract call. I think it's pretty cool. Okay, similarly, I didn't touch, but if we talked about different RPC methods, right? So if you wanted, for example, just to verify a storage slot, you wouldn't need all that. You would need just like a storage slot and the Merkle proof for this storage slot. And depending on the information you're trying to verify, your verification logic will change. Okay, so trustless, a heavy loaded word. So we know, especially I guess in this conference, nothing is really trustless. You always need to verify something, whether it's the hardware, the software, the cryptography, you trust something, right? So let's see what we trust in this light client model. Okay, so we have some verification requests to verify some balances. And the light client, it both syncs to the latest beacon block. As we said, this is what light clients do. They do it with light client updates. They get from a beacon API provider. We don't need to trust the beacon API provider. Why? The light client protocol itself cryptographically makes sure that as we increment in the blocks, it's correct. Like the beacon API provider can't fool us and submit us some wrong block. We can verify it with the light client protocol. And if you want some more details, look it up. The information is there. Okay, also we talked about getting proofs and all kinds of data from the RPC node, like the contract codes, the storage slots, and all the proofs. Do we need to trust the RPC node? No, we verify the proofs against the beacon block, which we assume we trust. So the RPC node can't submit us wrong proofs. It can submit us wrong proofs, but it won't make us believe something which isn't true. It just can like DOS us, withdraw information from us, and that's it. Okay, so it looks like magic. We can just verify some information. So where is the trust point? What do we trust here? So we trust the initial checkpoint. What is the initial checkpoint? We start to sync from some specific block in time, and from this point on, everything is kind of trustless, but we do trust the initial beacon block that we start to sync from. Why don't we start to sync from the very beginning? It's too slow. Currently, it will take too much time. It's not that slow. It's not like days. It's a couple hours. But if we want to like run it in the browser, just download the Chrome extension and start running. So it's not good enough for us. So we started some block, like a month in the past, which is kind of something we trust. Where do we get this block from? So the Ethereum Foundation maintains a list of such providers. You can check it out, and every provider tracks of beacon blocks that just happened, which are part of the chain. It's really recommended that you don't pick just the first provider, because as we said, this is all our trust relies on this one part. So it's recommended, it's also written in the documentation, to verify it against multiple providers, query all of them, query all the providers in the list, and get some checkpoint they all agree on. And then it's kind of good enough. Another point of trust is the light client protocol itself. So we said that regular nodes are like heavy and have storage requirements, but light clients don't. So how can this happen? So the light client isn't equal to the consensus protocol. So you run a different kind of protocol, which is more light, but also it has many benefits, but the minus side is that it doesn't provide the same security assumptions as the regular consensus protocol. So there are like active discussions and debates whether it's good enough, not good enough to introduce economic disincentives to slash malicious actors, etc. So if you plan to build on it, consider your use case. If it's a financial application that might be, it may be worth to attack the protocol just to exploit it. So it depends on the application. For our use case, it's kind of pretty good. It's good enough. Because currently there isn't any verification on the information you're seeing from Etherscan, for example, but also because the protocol is pretty robust. You can look into the details, but it's pretty good. Okay, so we see kind of how the verification works, right? And we talked about the trust assumptions. So we kind of trust something, but we can make sure that it's not really an arbitrary trust choice. It's pretty good. So what we would like to see in the future, so currently the extension works. You can just download it. It works fast. It's pretty amazing. Not like to brag or something. It just works. It does exactly what you expected. It can enable pretty amazing use cases if you plan to build with light clients, which we highly encourage and try to motivate you, and that's what we are doing in this talk. But what are some things that we want to look into? So we talked about the Beacon API provider, which supplies the light client updates. So currently it's kind of a bottleneck because the running providers are just maintained by the dev teams at the Helios, Lodestar, and other light client development teams. There isn't like a widespread adoption, so we want to see more of that. We want to see more provider suppliers get into this game, so it doesn't have to be such a bottleneck. Verifying other types of data, so we focused on contract calls, but as you saw with the RPC calls, you can verify anything that is on the blockchain. So it's transactions, staking data, anything you can imagine. Light clients on other blockchains, so we focused heavily on Ethereum. We know of some blockchains which there is light client ideas. Some of them lack implementations, some of them lack light clients at all. We would like to see it adopted in more chains because it enables amazing use cases. We didn't touch in this talk, but there are many use cases for light clients in general. And lastly is kind of an offline light client verifier. So as we saw, you need to constantly sync with the Beacon API provider, and you need to query the RPC node for the proofs, etc. And we are looking into a use case where instead of pulling all the data, the light client will be kind of in a push mode where you push the updates into it and the necessary proofs, and you just like provide all the necessary proofs and updates and get, this data is verified. So that would be useful in some scenarios we are looking into. This is currently being explored in the area of bridges, for example, which are offline. They don't have connectivity, so this is something that's progressing, aggregating the updates, aggregating the proofs, making it like compact. Yes, so there are a couple of links if you want to check out the extension, the repo, blog post with some of the details. And thank you.
Oh. So we have about like a minute and a half for questions. So if anyone has questions, yeah, feel free to just raise your hand and shout it out.
Hey, awesome talk. Thanks so much, Roman. Are Fireblocks customers actually using this extension, or will they be using this in the future? How do you see it going forward?
Yes, currently it's just in an exploratory stage. We don't require. We sent it to customers. We sent it to the community. We want to check out like kind of the feedback, how it feels. We are thinking of incorporating it later, not currently on the roadmap, but in Fireblocks products as well, in the information you're seeing from Fireblocks. So yeah, that's kind of the state of it right now.
Do you think that should be a default feature of all wallets then, not just Fireblocks?
We think if the technology will be robust and kind of easy and never crashes and all the bottlenecks we talked about and everything will just work, we assume that if it if more adoption will happen and one wallet will implement it and one website, so others will have to as well, right? Because why not? Because if one provides the information which is verified and the other doesn't, so you kind of have to keep up. So that's what we imagine will happen. Clients, it will come from the community. People will just require it, and the wallets will have to adapt and implement it.
Thanks.
Okay, we have time.